So we're going to move on now to solving trig equations, and let's just go ahead and jump right into it. So we're solving an equation that has a sine, cosine, or tangent in it. It could be secant, cosecant, and essentially you solve these like you would solve any equation. We're going to isolate first. You want to isolate the trig function. Okay, so right here our trig function is sine of x. So we want to isolate that. So we need to get rid of the -1 and the ×2. So we're going to add 1 first. So that leaves us 2 sine x equals 1. Then we need to divide by 2 to get the sine x by itself. So sine x equals 1/2. Right now the question becomes, when is the sine function equal to 1/2? So using the unit circle here, and our answers typically are going to be, we're going to think of them as between 0 and 2 pi. So any answer that works between 0 and 2 pi are the answers that we're going to use. So if we look on this, we're looking for when sine is 1/2. So sine remembers the y values. So right here, the y coordinate is y coordinate's 1/2. So the sine of 30 degrees would be 1/2, or you could say pi over 6. We're going to put radians as our answers, all right? So then let's keep going around the circle. Let's look for the y coordinate to be 1/2 again. Looks like y is also 1/2 right here. So 5 pi over 6 and pi over 6 are our answers. You keep going around, and now the y coordinates obviously down here are all negative because you're below the x-axis. So the only two we have are pi over 6 and 5 pi over 6. So our answers, x has to be pi over 6 and 5 pi over 6 if we're talking about the range between 0 and 2 pi. Okay, we're going to include 0 but not 2 pi. So this would be our answers as far as just telling us the answers between 0 and 2 pi. Now, we have an infinite number of answers to this problem, actually, because if you look at the graph of sine of x, right, if we graph it, we know we get the wavy line. Let me make my mode radians. So we get this wavy line, and it obviously is going to be at 1/2, here, 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 and it's just going to keep on going. It's going to be at 1/2 an infinite number of times. So if we want to indicate all of our answers, okay, all the way out to infinity, then what we need to do is write it in this way. So I'm going to write this in red. So we'd say pi over 6 plus 2 pi n, where n is some integer. Okay, it can be a positive or negative, because we know that if we add, if we've got pi over 6 as an answer, if we continually add 2 pi or subtract 2 pi, we go a full circle and we go back to where we started, right? So that's what plus 2 pi n is saying. It's saying add as many circles, add as many full circles as you want, and those continue to give you answers. Okay, so 2 pi n just means add 2 pi n number of times. So that's one, and then of course the other one would be 5 pi over 6 plus 2 pi n. For the same reason, if we go to 5 pi over 6 and add and subtract a circle over and over again, it's going to get us back to that same value. All right? So that's how you can write your answers. Either if it's asking you your answers just between 0 and 2 pi, then your answer would be the blue answers. If they're asking you for all the answers, you would want to write it the way we wrote it with the red answer. All right, so now that we understand this, I'm going to get rid of this right here. We might need it again. I'll pull back up if we do. All right, so let's do another one. So we're going to isolate the sine. Well, we have two of them, so we need to combine them together on this one. So let's add sine x to both sides. So on the right now we have 0, everything's gone. On the left we have 2 sine x plus the square root of 2. So now we need to get sine x by itself, just like we did in the last one. Let's subtract square root of 2, subtract square root of 2. So we got 2 sine x equals negative square root of 2. Now we divide by 2. So sine x equals negative square root of 2 over 2. So we're looking for the values again on the unit circle when sine is negative square root of 2 over 2. And whenever we look for those values, we're finding the y coordinate. Y coordinate is going to be negative square root of 2 over 2 at, let's see, 5 pi over 4. at 7 pi over 4, I believe. That's when sine's going to be negative square root of 2 over 2. And of course, you can write it with adding on 2 pi n to indicate all of the answers to this equation. All right, so go ahead and pause the video and try this one right here on your own. Now, the difference on tangent is that tangent has a period of pi. So, you know, we add 2 pi n. For tangent, you would just add pi n because it repeats itself every pi radians. All right, so go ahead and try that one, and we'll go over it. Okay, so for this one, we got to add 1, then you divide by 3, so you got 1/3. Now you got tangent squared, so you got to take the square root to get just tangent. So when we do the square root of 1/3, we got to put plus minus. So we got plus minus the square root of 1 over the square root of 3. Well, the square root of 1 is just 1. We got square root of 3 on the bottom, so you got to move it to the top and leave a 3 on the bottom. So our that simplifies down to plus and minus square root of 3 over 3. So now for tangent, when you look at the unit circle, you've got to look between just 0 and pi because tangent starts repeating itself after pi. Okay, it's got a period of pi. So what we want to do is look at when is y coordinate divided by the x coordinate square root of 3 over 3 or negative square root of 3 over 3. And so you might have to do a little math on this and divide some fractions. But right here, obviously, you got to use the points that have a square root of 3. So we're not going to use pi over 4 or 3 pi over 4 because those are square root of 2 over 2. We don't even have square root of 3s. So it's either going to be this one or this one depending on how the fractions divide out. So you might have to double check that, so I'll do that in blue real quick. So let's look at pi over 6. 1/2 over square root of 3 over 2. So if we do 1/2 divided by square root of 3 over 2, well, that's the same thing as 1/2 times 2 over square root of 3. And in that case, the 2's cancel. We get 1 over square root of 3, which is, of course, going to be square root of 3 over 3. So pi over 6 is going to give us positive square root of 3 over 3. And so that's going to be one of our answers. And then the point over here, 5 pi over 6, that's going to give us negative square root of 3 over 3. So those two answers both work. None of the other points between 0 and pi are going to give us square root of 3 over 3 or negative square root of 3 over 3. So our answer for x is going to be pi over 6 and 5 pi over 6. And of course you can write it to include all possibilities, pi over 6 plus pi n, right? Because we're talking about tangent. It's a period of pi, so it repeats itself every half a circle, all right? And then also 5 pi over 6 plus pi n. So we're not doing 2 pi for tangent, we're doing pi. Okay, tangent and cotangent repeat themselves every half a circle, not every full circle. All right, so those are our answers for that equation. All right, let's move on and look at ones that we might have to factor to solve. So this first one, we see cotangent of x, cosine squared equals 2 cotangent of x. So when you see that you've got common terms, right, there's not just like one type of trig function that you need to isolate. Right here we've got multiple trig functions and some of them are in common. Let's get them all on the same side. So let's subtract the 2 cotangent x. So I'm going to write cotangent x cosine x squared minus 2 cotangent x equals 0. So I'm going to subtract that to the other side. Now let's factor out what can be factored out. They both have a cotangent x, so let's take that out. So if I take out cotangent x, that's going to leave, in parentheses, cosine squared x minus 2. All right, now we have two factors multiplying to equal 0. So one of two situations has to happen. Either the first factor's got to be 0 or the second one's got to be 0 in order for them to multiply to be 0. So we got to set each of them equal to 0 to solve. So cotangent of x equals 0 or cosine squared of x minus 2 equals 0. All right, and then we can solve. So we got to add 2 to this one. Cosine squared x equals 2. And then get rid of the squared, take a square root. Square root, we got the plus minus. So cosine x is to equal plus or minus the square root of 2. Or cotangent of x has to equal 0. So for cosine x equals positive square root of 2 and negative square root of 2, this one is not going to give us any answers. All right, so no solutions can be gained from this one because remember cosine are your x coordinates, right? And if we look at our unit circle, we can see that square root of 2 is a number that's more than 1. All right, so positive square root of 2, negative square root of 2 is going to be more than 1 or less than negative 1. And these values, remember, they never get higher than 1 or less than negative 1, right? The x coordinates, the smallest it gets is negative 1 and positive 1. So for just a basic cosine function, you're never going to get a situation where it's going to be square root of 2 or negative square root of 2. So we're not going to have an answer for this part of the equation. So the only place we can get an answer is from cotangent of x equals 0. So looking at our unit circle, remember cotangent is x divided by y. Okay, just like tangent, cotangent only has a period of pi. It repeats itself every half a circle. So in this half a circle, when is x over y going to equal 0? Well, right here, when x is 0 and y is 1, then cotangent is going to be 0. And that is at pi over 2. So our only answer for this one is pi over 2. X is going to equal pi over 2 between 0 and 2 pi. Or we could say x is going to equal pi over 2 plus pi n, because it will repeat itself every half a circle. You'll get another answer. When we get down to the bottom of the unit circle, we get 0 over negative 1. So cotangent's also 0 down there at 3 pi over 2. Right? We add a pi to pi over 2, we get 3 pi over 2. That one we can see is going to be 0 also. Okay, let me show you what I'm talking about, just to make sure you can visually see it. Let's look at this again. So in this top half of the circle between 0 and pi, my only answer is right here, right? But this shows us that if we add pi n number of times, add pi as many times as you want, once, twice, 3 times, we're going to get another answer. So think, if I add pi to pi over 2, I'm going to get 3 pi over 2, right? Add half a circle, you get 3 pi over 2. Well, down here, remember cotangent's x over y, 0 over negative 1 is still 0. So I'm still getting cotangent equals 0 down here. If I add another add another pi, I get back up here again. If I add another pi, back down here, add another pi. So every time I add a pi, I'm getting to one of these lines where I'm going to get 0. So that's why I can just keep adding pi n number of times. Every time I add a pi, I get another solution. All right. So let's try this other one over here. Now in this one, you don't have a common, okay, so on the second one, sorry, I had a little issue. I had to cut the video right there, so, all of a sudden it jumped around and you wonder what the heck happened. I had to fix something real quick. So for the second one on B part, you see that you got 3 terms, 2 sine squared x minus sine x minus 1. So this one we're going to treat like a trinomial where you factor with x box or slide and divide. So we're going to slide the 2 over, multiply it by 1. So sine squared x minus sine x minus 2 equals 0. I do x box, what multiplies to be 2 and subtracts to be 1. That's 2 and 1. So we use a 2 in one parenthesis, we use a 1 in the other, and we use sine x in the beginning of each other. Because sine x is what's in the middle, right? I'm squaring sine x. So normally that would be x squared and x would be in the middle. So I'm just going to pretend that that's sine x now. Or that instead of pretending it's x, we'll just say it's sine x, right? So I'm going to use a minus now on just one of them, the big one. The other's plus. Now set each factor equal to 0. Sine x minus 2 equals 0. Oh, before we do that, sorry. We got to go back and divide. Alright, so we slid a 2. We got to go back and divide by 2. So 2 divided by 2 is 1. And then 1 won't divide by 2, so we got to put the 2 back in front. So it's 2 sine x plus 1. I set each of those equal to 0 now. Sine x minus 1 equals 0. 2 sine x plus 1 equals 0. Add 1. So our equation, we get our sine x equals 1. And then we subtract 1. Oops, that's an ugly negative 1, but that's negative 1, and then divide by 2. So we get sine x equals 1 and sine x equals negative a half. Okay, so we're looking on our unit circle now for when is sine 1 and when is sine negative a half. Alright, and you can see that we get sine to be 1, the y value is 1 up here, and that's the only spot. So pi over 2 is going to be one of our answers. then when is it negative a half? So when's the y value negative a half? Well, obviously nothing up here because this is where y is positive because we're above the x-axis. Down here, y is going to be negative 1/2 right there at 7 pi over 6, and right here at 11 pi over 6. So our answers are pi over 2, 7 pi over 6, and 11 pi over 6. So x is going to equal pi over 2, of course, plus 2 pi n, and then 7 pi over 6 plus 2 pi n, and 11 pi over 6 plus 2 pi n. Because if we do a full circle from any of those spots, we'll get back to those spots again and get another answer. So any of those values will be solutions to this equation. All right, let's roll on and let you guys do a U try. So you guys give this one a try, and then I'll go over the answer. Okay, so same thing I did on the last one. You had to slide and divide. Slide the 2 over, then x box multiplies to be 2 and adds it to be 3. That's 2 and 1. So we use 2 and 1, but then you've got to go back and divide by the 2. So we get sine x plus 1 and 2 sine x plus 1. Set each of those equal to 0. Subtract 1, so sine x equals negative 1. Subtract 1 and divide 2, so sine x equals negative a half. So we get that sine x has to equal negative 1, and we look at our unit circle and see that sine is negative 1 at 3 pi over 2. And then we look and see where is sine negative a half. Well, just like the one I did a minute ago, sine is negative a half at 7 pi over 6 and 11 pi over 6. So those values written in blue are our answers between 0 and 2 pi. Of course, you can add on the 2 pi n's to all of them to extend your answer out for every possibility to infinity. All right, so let's look at some other ones. This is says functions of multiple angles. This is essentially just ones where your variable, you're not just doing the cosine of x or the sine of x. You're doing like the cosine or tangent or sine of like 2x or a half x, something like that. So it's just going to change one more step at the end, but everything else is going to be the same. So right here we've got one trig function. We're just going to isolate that trig function like we did on the first example. So add 1. Then we divide by 2. So we get cosine of 3t equals 1/2. Now we've got to figure out when is cosine 1/2. All right, so you look at your unit circle and we see that the x values are 1/2 at pi over 3 and at 5 pi over 3. So 3t is going to equal pi over 3 and 3t equals 5 pi over 3. So this is where the difference comes in. All right, so we take the thing that's left over after we get rid of cosine. What's left over isn't x, it's 3x, or in this case 3t. So we got to set 3t equal to pi and 3t equal to 5 pi over 3. Then we can solve for t. So that looks like a 36. Let me make sure that y'all understand. That's not 36, that's 3t. Alright, so now I got to divide 3 and divide 3. So t equals pi over 9. And then you divide 3 over here, divide 3. So t is going to equal 5 pi over 9. Whenever you divide out there, it really just multiplies in the denominator. So there's my two answers for the cosine function. Now realize, of course, that that's going to be repeated every 2 pi. So you can add 2 pi into each of those to get all the answers out to infinity. Those are just the answers between 0 and 2 pi. Let's look at another one. Again, tangent. Remember on tangent now, the period is just pi. So it repeats itself every pi, not every 2 pi. So same process though, minus 3. 3 times tangent of x over 2 equals negative 3. And divide 3, divide 3. So tangent of x over 2 equals negative 1. So when is tangent negative 1? So we're looking on a unit circle to see when does y divided by x give us negative 1. And the only places that we're going to do that between 0 and pi is at 3 pi over 4, because we'll have negative square root of 2, or sorry, a positive square root of 2 over 2 divided by a negative square root of 2 over 2, which is going to give us negative 1. And that's the only value between 0 and pi. So remember, tangent, you're just looking at the top half of the circle. So we get that x divided by 2 has to equal what do we say, 3 pi over 4. And then to get rid of the divide 2, we're going to times 2. So here we times 2. So x is going to equal 6 pi over 4, which is, of course, 3 pi over 2. So our only answer is 3 pi over 2 within one period. But if we keep going, of course, the answers are going to be 3 pi over 2 plus pi n. And you're like, well, how do you know when to put the pi in or when to just leave it? Well, it depends on what they're asking. If they're just asking for the solutions between 0 and 2 pi, you don't need the pi n or the 2 pi n. But if they're asking for all answers, then you've got to have the pi n and the 2 pi n added on to show that you're going to repeat answers over and over again out to infinity. So you guys go ahead and do the U-try down here, and then I'll go over it. Let me know if you have questions. A quick snippet that I left off before we go on. So another difference on these types of problems where you have to divide by 3 at the end, this also has to divide our 2 pi n that we add on. So you don't have to erase this on your paper, but just let me show you what I'm talking about. So let's say right here at this step, instead of writing 3t equals our answers pi over 3 and 3t equals 5 pi over 3, let's say we went ahead and put the 2 pi n's in there. So we had 3t equals, what was it, pi over, let's see, a half. It was pi over 3 and 5 pi over 3, right? So we'll take pi over 3 plus 2 pi n, and 3t equals 5 pi over 3 plus 2 pi n. So if you want to write your answers like that with the 2 pi n's representing all possibilities, you also, when you divide by 3, you also have to divide that part by 3 as well. Okay, so that's the only reason I wanted to go back and show you this, is that you've got to divide that by 3 also. So t is going to equal pi over 9, which is what we had a minute ago, but this part you have to have 2 pi over 3 times n. And then over here you've got 5 pi over 9 plus 2 pi over 3 times n. All right, so that's n. Looks like a pi. Okay, only difference right there I wanted to show you was that you've got to divide the 2 pi n by the number, or multiply it by the number that you're dividing and multiplying by on these types of problems. So back here for this one, where we had x divided by 2 equals 3 pi over 2 plus, or equals, 3 pi over 4 plus pi over n. Well, now whenever we times by 2, we're going to times both of these by 2, right? So the fraction gets a times 2 up top, and this gets a times 2 also. So x is equal to 6 pi over 4, which is 3 pi over 2, plus 2 pi times n. So you got to multiply both of those by 2. So that makes it, the pi n change to 2 pi n. That's the only thing I wanted to make sure you understood on this that I didn't explain earlier. So let's do this one now, and we'll remember that when we get to the end. So I've already got the cosine by itself, so I can go ahead and look at the unit circle and see when it's cosine, the square root of 2 over 2. So looking at the full circle, the x-coordinate is square root of 2 over 2 between at pi over 4 and at 7 pi over 4. So we'll say, all right, x over 2 has to equal pi over 4 plus 2 pi n, or x over 2 has to equal 7 pi over 4 plus 2 pi n. All right, now to get rid of the divide by 2, same thing I did in the last part, I'm going to times 2. Of course, over here I times 2, and over here I got a times 2. So x is going to equal 2 over 4, which is 1 over 2, so pi over 2 plus 4 pi n. All right, and then same thing over here, times 2 to get x by itself, and times 2 right here, times 2 over here. So I get 7 times 2 is 14 over 4. 14 over 4 is just 7 over 2 plus 4 pi n. Okay, so our answers are pi over 2 plus 4 pi n and 7 pi over 2 plus 4 pi n if we're looking at values outside, 0 to 2 pi. All right, so approximating solution to the calculator. Some of these you can, find decimal representations using the calculator. So I want to show you how to do that real quick. This is pretty simple. So This should be the easiest part of the whole thing. All right, so I've got to approximate the solutions of x equals 2 pi x. So first, solve this to make it equal 0. So if I just subtract x, just subtract x to make it 0. So I have 2 sine x minus x. Now graph that on the calculator, and we're looking for when it equals 0, but more specifically when it crosses the x-axis. So 2 sine x minus x. And we graph it. Alright, so we can see the function right here, and we're looking for when it crosses the x-axis. We can see it's crossing. Let me zoom in a little bit. So we see these two values right here, or these 3 values that it's crossing at. So here's how you can find those answers. You use the root feature. So it's second calculate and 0. And then it says left bound, right bound. So we're going to move the cursor to the left of the x-intercept. And it says right bound, move it to the right and hit enter. And hit enter one more time. So we can approximate to the decimal negative 1.89 or negative 1.9. So one of my answers is negative 1.9. Now we do the same thing for the other two. Second calculate 0, but now we got to go to the other one where it's crossing. So somewhere to the left of there, hit enter, and right bound, so move to the right of it, hit enter, and hit enter one more time. So that one is 0, which is obviously what it looked like it was going to be. So x could be 0. And then do it one more time for the third point. Second calculate 0. Go to the left of the third 0 we have. Hit enter. Then go over to the right somewhere. Hit enter. And hit it one more time. And we get positive 1.895 or positive 1.9. So that's how you use the calculator to approximate your zeros. So go ahead and try the one down here at the bottom. Using your calculator, see if you can find those, and then we will go over. Alright, so on this one, you can see that when you graph it, you get a lot of different answers for this one. On the last one, it was pretty obvious. We just had those 3. So when you have a lot of different answers, the problem is usually going to give you some kind of restriction, like approximate the solutions of this between pi and 2 pi, or between negative pi and positive pi. Okay, so let's say on this one, we just want to look at the values between negative pi over 2 and positive pi over 2. All right, well, negative pi over 2 is negative 1.57. So we're looking at between negative 1.57 and positive 1.57. That's the only answers we're concerned about. All right, so let's zoom in. And you can even change your window on the x-axis to be negative pi over 2 and positive pi over 2. And now the only ones you'll even be able to see are the ones within that range. Alright, so looks like we've got it crossing somewhere in this value on the left side of my x-axis. So I'm going to hit second calculate 0. And I can't really tell where it's crossing at because it gets so close. So I'm just going to go out here to the end of the range of my window, hit enter, and then it says right bound. So I'm just going to go out somewhere to where it starts moving up, where obviously it's not touching the x-axis anymore, and hit enter, and hit enter again. All right, so my answer is negative 0.52. All right, that's the only solution to this one, is negative 0.52. If they give you the restriction that it has to be between negative pi over 2 and positive pi over 2. If there's no restriction, then you're going to get an infinite number of answers. It's going to keep hitting the x-axis here, 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 here. So on these, a lot of times, so you don't have to write an infinite number of solutions. They'll just give you a restriction on where you want your answer to be located at. All right, so appreciate your all's time. You can go ahead and start practicing. Let me know if you have questions, and I'll come around and help you.